Today's lecture, we're going to talk about dot product. So basically what it's saying here is that in order to multiply product of dots, multiply the dot product, you're going to multiply x's together and y's together and then add them up. So this is going to be x together and y together. You also have property of the dot product, where if u, v, and w is vector, then the commutative property works out, which means that when you're multiplying dot product, a vector of u times v is equals to vector of v times u. So same thing as if you're multiplying 2 times 3 is same as 3 times 2, right? Distributive property works out. If you have one term multiplied by two terms, you can distribute one term into the two terms. When you're multiplying two vectors, that will give you square of magnitude of the vector. If you're multiplying 0 times vector, you will get 0. 0 times any value is going to be equals to 0. That's where it comes from. You have an angle between vector. The angle between vector, long as the two vector is non-zero vector, then the angle between those two vectors have to be between 0 to pi. Cosine theta is equals to, having u and v as the two non-zero vector, it's going to be equals to u times v over magnitude of u times the magnitude of v. The dot product and orthogonal vector. So two non-zero vector v and w are orthogonal if and only if v times w is equals to 0, because multiplying one vector by 0 is going to be 0. And 0 vector is orthogonal to every vector. So let's look over the example 1. Let's say this is the one of the given vector v, and this is the another given vector w, and we wanted to find out the dot product. Let's see if we should be able to multiply. So remember, you can only combine the like term. So here, 5i and minus 3i will be the same term of I, so you should be able to multiply that value, 5 times negative 3. And then plus negative 2 times positive 4, because that's from the term of j, right? And when you multiply that, you get negative 15 plus negative 8, which is same as negative 15 minus 8. Same sign, so you add them up, it will get negative 23. If you have w times v, which is the same thing, it's just rotating. Let's see what we get. So we will do negative 3 times 5 plus 4 times negative 2 this time. But then multiplication's order don't matter, so you will end up getting exactly same thing, which is negative 15 minus 8. So your solution is the same as when you're multiplying vector v times vector w. What about you're multiplying the same vector v times vector v? So you will do 5 times 5 and plus negative 2 times negative 2, which you get 25 plus 4, which is going to be 29. What about finding the magnitude of the vector v? So this sign right here look like absolute, but you have a 2 of the line instead of 1. This is finding a magnitude. Magnitude is the distance, the length of that vector. The formula is going to be a squared plus b squared. Inside of square roots, a squared plus b squared. So your a is going to be 5, so it will be 5 squared plus negative 2 squared. You will get 25 plus 4, which is going to be square root of 29. So the magnitude of w is going to be square root of negative 3 squared plus 4 squared, which is 9 plus 16. So you end up getting square root of 25, which is 5. So that's how we're going to find the magnitude of the given vector. Example 2, it's a find the angle theta between the vector v and vector w round to the nearest tenth of degree. So if we wanted to have look at the picture of how does vector v and vector w look like this, where your vector v is right there, which is x value 3, y value negative 2, right? And vector w, x value negative 1, y value 4. So this is going to be the vector. So that's how it will look like. And what they're asking you to find is going to be the theta. So the angle between these two vectors. How do we do that? Well, we're going to use the formula. The formula we had was cosine theta is equals to v times w. So multiplying two vector over dividing by, that's what the over means, divide by the magnitude of the first vector times the magnitude of the second vector. Right, that's the formula. So we're going to use that to find the cosine theta, and then use the cosine inverse to find that theta. So when we plug in, we will get 3i minus 2j times negative I plus 4j. So that's both vector. And then find the magnitude of vector v will be 3 squared plus negative 2 squared times, this is all multiplications, and magnitude of vector w will be negative 1 squared plus 4 squared. So when you multiply the numerator, you get 3 times negative 1 plus negative 2 times positive 4 all over. This is 9 plus 4, and this is 1 plus 16. So you will end up getting negative 3 minus 8 on the numerator. And denominator is square root of 13 times square root of 17. So this is equals to negative 11 over square root of 221. So this is going to be cosine theta. So if that is cosine theta, so cosine theta is equals to negative 11 over square root of 221. So using that, if we wanted to find theta by itself, we're going to use the cosine inverse, right, of that value. So we can find the angle with the given value. And this is about 137.7 on the calculator. let's look at the next problem. Example 3. It's are the vector v and w orthogonal? So to be an orthogonal vector, remember when you're multiplying, it should be equals to 0, right? So that's the checking you're going to do. So let's try what happened when we're multiplying those two. So it will be 6 times 1. If you don't have any number in front of variable, you know that's 1, right? Minus 3 times 2. Well, you're actually doing plus negative 3 times 2, but that will be the same thing. And you will get 6 minus 6, which is 0. So is this orthogonal? Yes, because it's 0. Yes. Next example, it said, are the vector u and v orthogonal, parallel, or neither? So in order to see if these two given vectors are orthogonal, you wanted to multiply and see if this gives you 0, like the example 3, right? So that's the first testing I wanted to do to see if it's orthogonal. So you will do u times v, which is 2 times 3 plus 5 times negative 7. This is 6 plus, oh, that's negative numbers, which is negative 35. This is same as 6 minus 35, which is negative 29. Different signs, you subtract and get the sign from the bigger number. So this is not orthogonal. So nope, this is not equals to 0, not equals to 0, so it's not going to be orthogonal. How do we know if this is a parallel? Two ways of doing it. One will be actually graphing it, but when you're graphing, you're not 100% sure, right? So when you look at it as the graph, this is what you have. This is the u vector, and this is the vector v. So obviously, it's not going to be the parallel, but we wanted to also show you how we can tell if this is parallel or not a parallel, right? So if we can find this angle, if it's not 180 degree, then it's not going to be parallel, right? In order to be parallel look like this, having a same slope. So in order to be a same slope, you will have the angle of 180 degree or 0 degree, right? So let's see if we can find that. So cosine theta is, you're going to do, we already found u times b, which is negative 29 on the numerator, right? Denominator is distance. So distance, the magnitude of u and magnitude of v, you have square root of 4 plus 25 times, you have square root of 9 plus 49, which will give you negative 29 over, that's square root of 29 times square root of 58. And when you plug in those values, you will get around negative 0.7071. So if theta is that, cosine theta is that, your theta is going to be cosine inverse of that value. Plug in that into your calculator, it will give you around 135 degree, which you can tell it's not going to be parallel. So not parallel for that reason, and because it's negative 29, this is not diagonal. So this is going to be neither ones. So this is what we wanted to go over about the vector. Go over the homework problems, and if you have any questions, please let me know.